This is a video that's going to introduce you to a technique of factoring called grouping. First, we need to review a little bit about a greatest common factor. When you have something that's in common to both terms, like this big mess in parentheses here and this big mess in parentheses here, then that's considered a common factor, and you can take that out of each term as a factor and then write down what you have left. If I remove a big mess out of the first set here, then what I have left is a 2x. And if I factor out the big mess on the right, then what I have left is a minus 3. So the factored form here would be big mess times 2x minus 3. And I know that's a little silly, but when we get into grouping, these things that are in common aren't going to be single variables, so some people think of them as really being like a big mess. Here's another example of what it might look like when you start to have multiple variables involved. In this polynomial, I have 2x times the quantity y plus 2 minus 7 times the quantity y plus 2. And so that y plus 2 is a factor in each of these terms, this term 2x times y minus 2, and this term 7 times y minus 2. So if I want, I can think of that y plus 2 as a common factor, and I can pull it out and write down what I'm left with, which is 2x minus 7. So this is considered the factored form because these pieces, the y plus 2 and the 2x minus 7, are connected by multiplication. So that's why that's considered a factored form. So now let's look at something that doesn't have something obviously in common in all of the terms. If I look for a greatest common factor in all four terms, I don't see anything that's common to all four. These first two have something in common. The 2y and 14 have something in common. The 7 and 14 have something in common. But when I look at all four together, they don't really have anything in common. So when I have four terms with nothing in common, one strategy I can use is to group them. And when we say group them, we mean take two at a time and see if maybe I can just find a greatest common factor for two of them. So in these first two, I've got an x in both terms. So I'm going to take an x out as a common factor, and what I'm going to be left with is a y plus 7. Now I'm going to ignore that I did that, and I'm just going to focus on these last two. When I look at the 2y and the 14, there's a 2 in common. And when I look at what I have left, if I take a 2 out as a factor, I'm left with a y plus 7. And now what you'll notice is that both of these groupings have produced this common factor of y plus 7. So now, just like I did in the earlier examples, I can treat that like my greatest common factor of y plus 7 and then write down what I'm left with, which is x plus 2. So the factored form is y plus 7 times x plus 2, or if you wanted to write it the other way, with the x plus 2 first and the y plus 7 second, you can. And remember that the way you can check that is to distribute. So I'll take this second one here, x plus 2 times y plus 7. If I distribute, I get xy plus 7x plus 2y plus 14. And because this is what I started with, these are the correct factored forms. One of the common questions that I get about grouping is, does it matter the order that I put the terms before I group? Some people might look at this 7 and this 14 and think, oh, there's something in common there, I should put those next to each other. So if I rearrange the terms and I put the xy next to the 2y and then I put the 7x next to the 14, will I get the same answer? So let's see. If I do the technique again, I look at them two at a time. I just look for a common factor between those first two. That's a y. And I write down what I have left, which is x plus 2. And then I look at what's in common in these last two, and that's a positive 7, so I put plus 7. And then what I'll have left is x plus 2. And you'll notice that I have a greatest common factor now that shows up. Both of these terms have this x plus 2, which means I can pull that out as a greatest common factor. And what I have left is a y from this term and a plus 7 from this term. And the factors are again x plus 2 times y plus 7, and that's the exact same thing I got when they were in the other order. So you can rearrange them in whatever order makes you feel most comfortable, but no matter how you rearrange them, you should get the same answer. So let's do one more with higher degree. I've got an x cubed here. So same thing, I'm going to look at these two together and these two together. And when I just focus on the first two, I've got an x cubed and an x squared. So that has a greatest common factor of x squared. And then I'm going to write down that I have an x minus 2 left. And then if I look at this second set, I believe 3 divides into both 3 and 6. And if this is a minus here, I often get a question, should I take out a minus 3 or a plus 3? And the answer really comes from knowing that you're trying to get this x minus 2 to repeat itself over here. So if I know that in advance that I want what's in the parentheses to be the same, then in this case, if I have to have an x minus 2 in the parentheses, it's going to mean I'm going to have a minus 3 here. Again, because negative 3 times x is negative 3x, and negative 3 times negative 2 will give me this positive 6 back. Now I've got a common factor of x minus 2, so I can write this as x minus 2 times x squared minus 3, or if you like it organized the other way around, x squared minus 3 times x minus 2. And again, if you want to check this, you're going to distribute x squared minus 3 times x minus 2. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Negative 3 times x is negative 3x. And negative 3 times negative 2 is plus 6. And if you compare this to what we started with, they're the exact same thing. So that means that these answers over here are the correct factored form. So this will be the last example. 10x squared minus 15x minus 8x plus 12. Looks like there's something in common in each of those, so I'm going to leave them in the order that they are. And when I look at the first two terms, I believe a 10 and a 15 have a 5 in common, and there's also an x in common between the x squared and x. So I'm going to pull out a 5x, and what I'll have left is a 2x minus 3. And then when I go to the second grouping, the 8 and the 12, I believe 4 divides into both of those, but there's often a question, should I take out a negative 4 or a positive 4? And one more time, the way I know what I'm supposed to do is I actually cheat a little bit, and I assume that I'm going to get this 2x minus 3 again over here, because that's what I want to have happen if I can really group it. Sometimes it won't happen, and in that case you can't factor the whole thing at all. But in this case I can, and if I put a 2x minus 3 over here on the right, in order to get this negative 8x here, I have to have a negative 4. And then again, negative 4 times negative 3 will give me the positive 12 again. The 2x minus 3 is in common, so my factored form is 2x minus 3 times 5x minus 4, or if you like it in the other order, you can write 5x minus 4 times 2x minus 3.